guys ready? I'm Gary Bernhardt. I look like this on the internet. I look like this in real life, sometimes. I run a company called Destroy All Software that produces screencasts on various advanced development topics. And the title of this talk is Deconstructing the Framework. It's about web frameworks. I use Rails as an example. It's not Rails specific. And it has 5 different parts, the first of which is design in the small. So the design of small, fine-grained pieces. And I'm going to use one very specific example. I'm sure you've seen code like this in Rails apps before. I have a comment model, active record model. It has an after create callback that notifies all commenters. So this is the behavior that GitHub gist has, for example. You comment on a gist, and for the rest of time, you will receive notifications, and you can't turn them off, sadly. You guys should fix that. The problem with designing things in this way is that you end up with a system where all your tests are testing some system under test. The systems under test are using model objects, and the model objects want to send email or want to hit an external system of some kind, whatever that system is. Rails happens to turn email off for you in tests, so email is not a big deal, but other external systems are a problem. So you end up, first of all, having to stub the external system to create your model objects, which seems extremely wrong to have to do that. And you also end up with this situation, which I'm sure you guys have seen before. You break the external system, and suddenly all your tests break because they all depend on this thing that really wasn't relevant to the test or to the model object. The fundamental problem here is that the record is coupled directly to the API. The active record object is coupled to the API. And the obvious solution, as with anything in software, is to add a layer of indirection. So if we create a service that aggregates the process of creating a user or creating a whatever, it can make the record, it can hit the API, it contains that logic. And here's the same example done that way. So this service posts comments. It creates it in the database. It then, for each of the commenters in the thread, it emails them. And now the active record object has no coupling to the external system, to the email server. This is a small, sort of obvious example, but it's going to motivate the rest of the talk, starting with services, wrappers, and records. This is sort of the minimal web application architecture that I think makes sense and can scale you to what we would probably consider a medium-large Rails app, which of course, in the grand scheme of things, is not that big. The idea is that you have services, things like I just showed you, stateless objects with behavior but no data in them. The services will talk to records. These are the things in the database. And the records are very simple, and they're very thin layers over the actual database itself. So for example, here's what I'd like an active record to look like. This is an example taken from the Destroy All Software Sucks Rocks series of screencasts. It's a cache score. This is a system where you type in a word and it tells you how good it is based on what the internet says. So if you type Ruby in, it will Google for Ruby rocks and Ruby sucks, so very English-centric. And it will compute a score from the relative numbers of results. I have 2 methods in it only, the first of which saves a new score. It's a very thin wrapper around create, as you can see, but it narrows the interface. So it takes exactly 2 arguments. They have to be there. There's no ambiguity. It also gives me a point that I can stub in my tests that I control, so I'm not afraid to stub it, or I'm less afraid to stub it. And it hides any changes in Rails that might come. Now, create bang probably is not going to change, but if you think about Rails 2 to Rails 3, the whole query API changed a lot, and basically everyone was screwed. If you had a Rails app at that time, I'm sure you remember, it sucked because you probably had controllers that were calling the querying API, query API changed, bad times. So this prevents that as well in the future. And the second method there is the query method, speaking of queries. It finds a single term and returns the score. And the interesting thing about this is that it's a function from a string to a floating point. It does not return any model objects. In fact, the rest of the system never actually sees a cached score. It sees the numbers, it sees the terms that it asks for, but it never sees the actual active record object. In general, I want my active record objects to load things, save things, update themselves. So like change password might be a method I would put on there. It might have to change multiple fields at the database level, but it provides a slightly higher level update. And then very simple aggregate functions like full name is first name plus last name. So those are records. And the third thing is wrappers around third-party APIs. So in that same system that I built for those screencasts, I had a search engine class, and this is how I search for those phrases. It's an extremely simple wrapper around rbing, which is a Ruby Bing library, 2 lines of code, as you can see. But these 2 lines of code give me so many benefits for the design and especially the evolution of the system. It gives me a place to stub in my tests if I want to. It protects me from changes in rbing. It also allows me to swap the entire search engine out if I want to for Google or whatever. So there's all kinds of advantages to writing even these 2 small lines of code. And finally, in this very simple application architecture, services can call other services, so they can be aggregates, and you have a tree of services is what ends up happening. So this is the simplest way I know to design an application that will grow reasonably over time. It won't turn into a ball of mud with your 1,000-line controllers, or if you read Skinny Controller Fat Model, your 1,000-line model, which has exactly the same design problems. Which, speaking of 1,000-line things, brings me to part 3, the squishing rule, which I'm going to motivate with everyone's favorite principle, the SRP, often quoted, rarely understood. A class should have one and only one reason to change. So I thought we would go through, very briefly, and look at the reasons to change that your typical Rails controller has. They tend to do authentication, so that's a reason to change. They tend to do authorization, which of course is different. That's a reason to change. They tend to wrap HTTP in both directions. So coming in, you have params and headers. Going out, you have status code and headers. Reason to change. They tend to manipulate the model, calling methods on active record objects that you defined. That's your model. They tend to manipulate the database, which is actually a different thing. If you call the reload method in a controller, that's not model. Your application conceptual model doesn't have reload in it. Reload is a database idea, and it's an idea that not all databases even have. So the controller, if it calls reload, has knowledge about the nature of the underlying data store. So another reason to change. They often query the database, controllers do, which means they understand the structure of the database and the way the data is organized. They often present models, and that could be something as simple as computing aggregate values from single columns, or it could be something like group by, where you're aggregating several objects. They often contain view content, so a flash is content pushed into the view to be rendered. They often contain response content, which is, for example, rendering JSON. That is actual literal values that will be output to the client. They often do routing, not on the way in, hopefully, but on the way out. Conditional redirect is routing. They often choose the content type, and they often contain model logic, which is the most sinful of all of these. You should never have model logic in a controller, in my opinion. So the single responsibility principle says a class should have one and only one reason to change, and this is the one reason for a controller to change, which doesn't seem right to me. That does not seem like good design. And I'm not a fan of treating the SRP or any principle as an absolute rule, but as a guiding principle, it seems to indicate something is wrong. So the squishing rule, which I propose here to you as certainly a much simpler and easier to understand idea than the SRP, is that if you take a big thing and you just cut it in half, the small squares are exactly half the area of the big one, don't worry. If you take a 400-line class and split it into two 200-line classes, probably the 200-line classes are better designed, even if you split it poorly. Even if you choose the wrong line to draw, they're probably still going to be better designed. So that's part 3 of the talk. We've so far had this minimal architecture for a Rails app, and we've had this rule that I basically argue by I don't know, my own intelligence, that if you squish something, those pieces will be better. So now I want to put these two together and consider the decomposition of a controller, especially in a Rails app, but really just the whole Rails app. What is it actually doing? If you look at the things Rails gives you, this is basically what you have, putting things like helpers aside. Things come into the route, things go out of the template, and in between you have a controller and a model. And this makes it very obvious why there have only been 2 architectures that were popular. Originally there was fat controller, skinny model, and then it got inverted, but now what? There's no other option if you only have controllers and models. So let's start decomposing and figuring out what is actually going on in here. Well, presenters have become popular. They're really just object decorators. Rails culture has this weird thing where it uses the wrong words for everything. But I like the idea. It's cool, so let's put it in there. That was something the controller used to do in 2006, let's say. It was very common. And now we pull it out into a separate object. The model here is really, we can really separate the reads and the writes. And suddenly we've exposed boundaries in the system that were not obvious before. Reading is actually a boundary, and writing is a boundary. And furthermore, you can actually do the reads in many cases based purely on the route. So based on the action you route to, before you call the action, you could theoretically pull all the data out of the database that it needs, give it to it, let it do its thing, and then when it's done, write it all back. It's a perfectly reasonable thing to do, and it's sort of what the unit of work pattern is meant to do. Of course, you need entities, so let's put the entities in between. Those are the active record objects. You can do the same exact thing for HTTP. If a route is matched, you can, in almost every circumstance, immediately pull out all the headers it's going to need, the params it's going to need, and pass them into the controller. The controller doesn't need to know about them, because for 99% of controller actions, the headers and params used are the same in all cases. And then after the controller's done, we could do a write, a high-level write. So a high-level HTTP write would be something like redirect to. That's a pretty high-level idea. It translates into a status code 304, I'm guessing, and a location header. But you don't say 304 and location header, you say redirect to. Continuing on to in decomposition, I've become confused. What changed? Oh, yes. So when you pull out HTTP stuff and database stuff from the controller, you really just have logic left. That's sort of what you have. It's like a service class, or it's like an interactor if you've seen Uncle Bob's talks about this kind of stuff. So continuing to decompose, there's a value being communicated between this logic, this controller, and the presentation. So let's put that in here just to be clear that it's there. And the HTTP write can come out of that. It's sort of straightforward, obvious kind of thing. And finally, this is the really weird one, but I have this thing that I'm kind of obsessed with, which is routing is not just about verbs and URLs. It's about the state of the world relative to the user making the request. So I really think that authorization is a routing concern. I think that the router I should be able to say to my router, this URL or this route matches verb X, URL Y, and state Z of the world. And state Z might be users and admin, or user is authenticated. So that's another thing we can pull out of the controller. And you can see this is a heck of a lot more complicated than what we started with, or at least it looks that way. There's a lot more pieces. But all these pieces are there. These are all things you're doing. It's just that if I color this differently, the dark parts are what you normally put in a controller in traditional Rails design. If you do skinny controller fat model, it changes slightly, but not that much. So all these different things are going into the controller, which is sort of unfortunate. And when I tell people this, they have a hard time imagining how I would fix it. What would the code look like if it weren't like this? So I made that code. I made this thing with my friend Tom Crayford called the Raptor Web Framework. It is an experimental framework. It's not designed for building applications. It's designed for proving that you don't need things to be in giant, ugly controllers or giant, ugly models. So here's a Raptor application. This is actually a complete application, assuming there's a database layer for it to talk to. This is sort of like saying, what would the Rails equivalent be? Resources, users, only create? Yes, only create. It's like saying that. Underneath the hood, it's translating into this. This is what Raptor's actually doing, creating a route named create. It accepts posts to /user because it's in the /user path. The second line is what it's routing to. This is a path to an arbitrary method in the system. So there's no idea of controllers. It just routes to some method. And line 3 says if it succeeds, redirect to show. That's what you normally want to do on create, right? You make the thing, you redirect to show if it succeeds. If it throws a validation error, then you should re-render new because there are errors and you want to re-render the form. So in other words, in Raptor, by saying the word create, you get the standard Rails create behavior that you would have coded by hand in normal cases. Usually you're going to override the target of the route. So this is sort of like specifying the action you would run in a Rails controller or in a Rails route. and it's just an arbitrary method path. And then the method might look something like this. It's in a plain old object, no base class, and it takes the params as an argument and then does whatever it needs to do. In this case, it's creating users, so it makes the database record and then hits Braintree, which is a payment system, to put a record in there as well. Now, there's an important question that this should be raising in your mind, and I hope it is, but before I get to it, so far we have routes. We have routes that delegate to services, and the services hit some kind of database layer, but the services in the database layer are your problem. Raptor doesn't tell you how to do those. The question that should have come up in your mind, though, is what's with the params? Controllers need more than params. Sometimes they need headers, sometimes they need current users, sometimes they need cookies or session state. They need all kinds of stuff. There's like 800 methods, I think, currently on action controller base. And Raptor doesn't have action controller base. It actually doesn't have any inheritance in it whatsoever. Instead, you get arguments, but the arguments can vary. So your one service, the top service there, wants params. The bottom service wants current user and params. And the way that this works is that Raptor does, in fact, have an injector, but it is not a container. It's not an IOC container. There's no configuration, and I don't mean there's no XML. I mean you can't configure it. There's no configuration to do. It's purely name-based. So when I have a method that takes current user and params, Raptor knows params out of the box. Current user is actually one that you will define using a fairly simple method, telling Raptor what current user means, and then whenever it sees an argument current user, it'll pass the current user in. Raptor also has requirements on routes, which are like the guards that I mentioned earlier, things like authorization, and they look like this. I have a route update. It requires an administrator. Only an administrator can do it. What does that mean, though? Raptor doesn't know administrator. It doesn't have auth built in. Well, I define a class, my app, whatever your app name is, :requirements, :admin. Raptor will look that up based on the fact that you're requiring admin. The injector will inject the current user argument because it happens to take it, and then the match method will return true or false for whether the route should match or not. So much like you can hook into the injector, you can hook into the router and specify arbitrary high-level requirements with this sort of conventional name-based interface. And there's lots of other stuff about Raptor. I don't want to go on and on about Raptor because I don't think it's very interesting, and this talk isn't about Raptor. But Raptor doesn't have controllers, and it actually works as a web framework. I mean, we've not built production applications in it or anything, but you can look at pretty much any Rails controller and figure out how to decompose it into Raptor, and then it makes much more sense. All the concerns are separated. Routing is in one place, logic is in one place, and the injectors tend to be sort of a junk drawer, but they tend to have single responsibilities. Of course, the real graph looks like this. The injector's everywhere. Every time Raptor calls your code, it injects, and it doesn't inject arbitrary method boundaries, but whenever it calls you, it injects if you want anything. You don't have to use it if you don't want to. So Raptor is a real thing. You can go to GitHub and find it and download it. It's been there for over a year. But once again, my point is not Raptor. Raptor is an existence proof that you can decompose applications into pieces that make more sense than just, well, the request comes in and there's a controller action. That's my architecture. I have a function. It's not much of a design. The more immediate point that I hope you take away from this is that stateless services will help you to decouple your persistence from other bits of the system, and you want that. And simple third-party wrappers will help protect you from changes in other Ruby gems or services. Ruby has a culture of rapid change and not a lot of regard for backwards compatibility, so you really want to insulate yourself from that chaos in the ecosystem. And these two things, I think, should be on one side of a very important line in your application, which is the Rails line. And on the other side are very simple active record objects and then Rails. And you want those things away from your services and your third-party wrappers because you want to be able to test without Rails, and you want to insulate yourself from the chaotic nature of Rails over time, to be honest. The 2 to 3 transition demonstrates that things don't always go so smoothly when you upgrade. So that is the end of the talk. I realize it's sort of all over the place, but I hope you get something useful out of it as far as thinking about what an application does, what are the pieces of it, especially what's a controller doing, and what should a controller be doing. So once again, I'm Gary Bernhardt. I own Destroy All Software, which produces screencasts on things like OO design, TDD, and also all of this stuff, basically. There's a series called Sucks Rocks that I took the examples directly from, and it talks about exactly these things. So thank you guys very much for listening to me for 20 minutes.
Any questions?
Hey.
Hey.
So basically, I've been trying to use some of those paradigms that you expose in Destroy software. And I find that for some things it works really well, especially when you deal with pretty simple input-output, scalar value, strings, and so forth. But oftentimes in Rails, we really do create a lot of CRUD applications, and it doesn't feel like it scales to that really, because oftentimes you add a validation to a module, which really just is a view concern often, like putting in an error message. Right. And that just works. And the just works part is the bit that drives Rails people, right? And I feel that it's difficult to get there.
Yeah, it's the problem with Rails is that it is so opinionated that the more design you impose, the harder it becomes. And so Uncle Bob, for example, has been talking about design and web apps, and the design, the sort of architectural vision that he describes is quite complex. There are a lot of moving parts, and he advocates complete separation of basically your application from the web framework like Rails. And in Rails, I don't think that makes sense. I think that is far too much. Basically pulling out services, which is the core of what I advocate, I think does make sense. Not all the time. For example, that validation case, yes, it is a view concern. Yes, sometimes it's a view concern. Yes, it's easier to put it in the model, and that's probably what you should do. Because if you fight that, you're going to end up writing 20 lines of code to avoid writing the one line in the active record class. So I try not to take it to an extreme, but as long as it doesn't hurt, oftentimes it won't hurt. Like the cases you mentioned, sometimes it really is nice. And in those cases, it'll be obvious that it's nice when you do it. And that's when I think it can be really beneficial. Even if 75% of your app was built with services and the other 25% was plain old ball of mud Rails style, it's a huge improvement. We have one in the middle here.
Yeah, as pointed out prior about the validations, a lot of the beauty of Rails lies in the meta programming and DSLs. Was it a conscious decision? I mean, of course it was probably, to go the same route or even drive that further, because I thought the decomposition aspects were really clear, and going into a layered architecture, having some kind of domain-driven design input in that. But I thought kind of that having a more clear, like using the basic APIs of Ruby itself approach would also be beneficial for
The basic APIs like the core types? Or
yeah, exactly.
Oh, okay. I'm not entirely sure. Can you give an example? Oh, you've lost the microphone.
I gave it away. When you use the DSLs to define your actions, and you have the injector, which is a cool thing, I guess, but where you actually have everything in these DSL calls, what you basically do, where you could rely basically on the libraries that provide output and stuff, so make it more explicitly in the core, so that you just use what's basically there and not define like a layer of DSL in between.
I'm not impressed by the extreme level of sort of DSL obsession that Rails took as a design. I mean, if I were building a web app today, I would probably use Rails, right? So it's not as if I think it's awful or anything, but I think it takes it very far, and in many cases hides intent. There are a lot of cases, in active record especially, where if you just define a method, it's like one more line, and then you know exactly what it's doing. And so that's one of the reasons Raptor doesn't actually touch the database layer, because it's hard to do that tersely without introducing lots of confusing stuff. The only actual DSL in Raptor is the router, and it's a pretty complex one. But other than that, there's nothing. It's just all methods all the way down, methods with arguments. I don't know if that answers your question at all, but are we on time? Still good? I guess so. There's one over here, far away from all the microphones. Everyone's waiting so nicely during my questions. I don't know why I'm special.
Yeah, I'm also concerned a bit about their magic router stuff. What's about connecting it with Ruby Web Machine instead? The Web Machine by Sean Cripps. I know it has some issues with rack and so on, but like going this direction wouldn't be the nicest way, you think?
Let me make sure I understood. You're asking about integrating something like Raptor into like Heroku, deploying it.
Actually, no, to Web Machine by
Web
Sean
Machine.
Cripps.
Oh, I'm sorry, I misunderstood. I have no idea. I'm not super into the whole async thing, so I haven't paid a lot of attention to Web Machine.
Yeah, because I really like how Raptor is designed by all the constraints and nice design. But the router is like very magic thing in there, and I didn't like it that.
Yeah, it is very magical, and that's the thing. The router had the most design put into it, and it's the part I'm the least happy with. I think I have a lot of respect for Rails after writing that router. And ours is, the router in Raptor is, I would guess, 150 to 200 lines. It's extremely simple.
Actually, I was playing with router in Padrino, and after that, I don't have respect for routers. Because for me, it's a useless thing. I have respect for Web Machine right now. It's awesome design.
The thing that makes me want to design something like Web Machine is the fact that it bakes the protocol in, right? The protocol is Web Machine. Web Machine is the protocol. It's like one. Or wait, am I confusing Web Machine with? No, Web Machine is like a direct implementation of HTTP where the state transitions are and we thought about doing that, but we just could not reconcile it with what we wanted an application to look like, especially the router. And because Raptor's router routes on everything from like a verb, an HTTP verb, all the way into model level stuff, like you're an admin or not, and we could not figure out how to fit that into a Web Machine style model. It's like two fundamentally different ways of slicing the problem, is encode the protocol directly or build your own thing that uses the protocol.
Okay, thanks.
Yeah.
Great presentation, by the way.
Thank you. I guess we still have time. No one's kicking me off. One more? I can't see very well. I don't think we have one more. All right. Thanks, guys.